Okay, question number 3. The nerves that supply sensation to the front portion of the person's foot run between the long bones of the foot. Tight-fitting shoes can squeeze these nerves between the bones, causing pain where the nerves swell. This condition is called Morton's neuroma. Because most people have a dominant foot, muscular development is not the same in both feet. People who have Morton's neuroma may have the condition in only one foot, or they may have it in both feet. Investigators selected a random sample of 12 adult female patients with Morton's neuroma to study this disease further. The data below are measurements of nerve swelling as recorded by a physician. A value of 1.0 is considered normal, and 2.0 is considered extreme swelling. The population distribution of the swelling measurements is approximately normal for adult females who have Morton's neuroma. And here's the question. Do these data provide convincing evidence that the true mean difference in swelling of the dominant foot and in swelling of the non-dominant foot for adult females who have Morton's neuroma in at least one foot differs from 0? Complete the 4-step process. All right, this is going to be a paired T problem. The reason we know that is because we have 12 individual people and they have these measured swellings on both the dominant foot and the non-dominant foot. So what we'll do is we'll get those subtractions between all 12 of those, and we're going to use that one set of data and put that in the list. And we're going to run a test. And we call that a paired t-test or a one-sample t-test for paired data. And the reason it's a test is because of the statement at the bottom, do these data provide convincing evidence? So that right there is going to lead you to believe it's a test. And for your alternative hypothesis, the question states, is there reason to believe that swelling differs from 0? So differs means not equals to. So let's go ahead and kind of start the process of setting up this test. For paired data, most often you're trying to see if that difference compares to 0. So your null will always be equals the mu d, and notice I have a little subscript d for differences, is equal to 0. The alternative is not equal to, because of this right there, differs from 0. And I'm going to define mu d as the true mean difference in swelling dominant foot minus non-dominant foot for adult females with Morton's neuroma. And I'm going to use alpha at 0.05. For our data, it says one sample t-test for paired data. So we're going to just state the test we're going to use. So it's a one sample t-test for paired data, or a paired t-test. And the question's talking about a random sample of 12 adult females were taken. You can go up here and you can see right there, a random sample of 12 adult female patients with Morton's neuroma to study this disease further was taken. So we're going to restate that. The 10% condition is met because we selected 12. I assume that 12 is less than 10% of all adult females with this condition. And the approximately normal condition, while it does state that in the problem, it is the population distribution of swelling measurements is approximately normal. We have to really look at the difference and see if that difference in our sample, because our sample is 12 and it's pretty small, we should still check that that graph. So what you're going to do is you're going to put those data in your L1. So if you haven't done so yet, you can pause the video and do that. Just get that differences and put them in L1. All right, now that you got that in there, turn your plot on, second y equals, and we're going to go ahead and look at a box plot. Check for outliers and strong skewness, and then do zoom 9 to put that on your graph. And that's fairly symmetric. So I'm just going to plot that on the paper real quick. And we're looking at, that's a little bit, maybe something like that. And I'm just going to state the box plot of the differences shows no strong skewness or outliers. So we are ready to crunch these numbers here. We're going to use the calculator to get all this information. So as far as the do goes, if you got your data in L1, you're going to go right over to stat, go to test, and this is going to be a one sample t-test or just t-test in your calculator. And we have the data in L1. Mu, the null hypothesis is 0. We're trying to test not equal to, so we'll leave it there. And I'm going to go ahead and calculate that first, and we're going to get the two most important things on this, the t and the p value. So the t and the p value. Now look at that t, that's your test statistic, 10.68, and your p value of 3.81 to e negative 7. I'm going to list all of this information out since none of that was provided in our set of data. So let me see, make this a little bit smaller. And we'll just kind of jot that down over here. So using technology from the calculator, it's going to be a 1 sample t-test. And we're going to record t is 10.68. And it doesn't say the degree of freedom, but the degree of freedom is just going to be n-1. So we're going to say degree of freedom is going to be 12 minus 1. If the calculator reports the degree of freedom as a decimal, that's from 2 samples, and it uses a more accurate degree of freedom. But in this case here, it's just going to be 11. So let's go ahead, just kind of throw that on there. P is 3.81 e negative 7. So really, that's your p value. That's the most important thing. And 3.81 times 10 to the negative 7 is a very small number. It's actually 0.000000381. So it's effectively nothing. And I'm going to record our mean and standard deviation. So our mean difference, I'll put a little d there, is 0.2875. And our standard deviation difference is 0.093. And really, these two are the most important things, but I would go ahead and make sure all that other stuff is listed, especially since it's not up there given in the problem. So once we have that information, we're going to make our conclusion. And because our p-value is so small, since p-value of 0.000000381 is less than alpha, what are we going to do? We're going to reject HO. We have convincing evidence that the difference in swelling between dominant versus non-dominant foot is different from 0 for females with this condition. So we're going to reject HO. Basically, p-value is so small, reject the null hypothesis. We have convincing statistical evidence to conclude the difference is not 0. All right, that is number 3. Thanks for watching.